Hello, everybody, and welcome to our webinar today. As we give people a few more minutes to join, why don't you go ahead and pop in where you're joining us from in our chat box today. I'm going to highlight that on your screen. So go ahead. We'd love to see where you're joining us from. All right, I'm seeing Cologne, Manchester, Michigan, Kiev. We're really seeing a nice global audience so far. I don't know how the weather is everywhere else, but I am in Colorado, and we have had really nice sunshine, which is very nice after we got 2 feet of snow last week, which was a little bit crazy. Nice to have some sunshine. Dallas, Northern California, more Texas. Great. All right. People are still coming in, but I think we can go ahead and get started. Hello, everybody, and welcome to today's webinar. My name is Molly Lord, and I am a member of the team at Scrum Alliance, and we are so excited to have you joining us here today. So in case you aren't familiar with Scrum Alliance or you got your certification and you're just learning about us, we are a 501c6 nonprofit that was established in 2001 after the signing of the Agile Manifesto, and we have awarded over 1,876,000 certifications since our establishment, and we have members all across the globe. I believe we're in almost every country at this point, which is incredible to see. And our mission is to advance real-world agility by equipping and inspiring the change maker in everyone. Just one of the reasons we're here today, to help give you a new skill for your Agile toolkit. And if you are a Scrum Alliance member or you're interested in getting your first Scrum Alliance certification, wanted to do a little quick overview of what being a Scrum Alliance member can do for you. It gives you access to all the Scrum Alliance Learning Journey courses, which are thoughtfully created by members of our trainer and coach community and are an incredible asset to you on your Agile journey. We also help connect you to the Scrum Alliance global community. As I said, we're all across the globe, and so there are different ways you can connect with people, whether that's regional Scrum gatherings, our global Scrum gatherings, or local user groups within your community. You also have access to member benefits like the Retrium retrospective tool, as well as a suite of comparative agility tools, such as the comparative agility tool, which helps you survey your team and learn how you can improve your agility, as well as the Scrum Master and Personal Improvement tool and the Product Owner Personal Improvement tool. Before I hand things off, I'm going to give you a quick tour of your webinar console today. So as you can see, there's a media player and slides where you can see our video as well as the slides for today's webinar. In the webinar, we'll be talking about some content, and so you should be able to find the content link in the related content section. If you have a question for our speaker today, please throw that in the Q&A box, and we'll make sure to try and get to that at the end of our webinar. And then please, throughout the webinar, and some of you are already doing this, be sure to react. Give us a smiley face, a heart, a thumbs down. Just let us know how you're feeling about what's being talked about at the moment. It's really great for us to go back and see what y'all are thinking. Without further ado, I'm going to hand it off.
Excellent. Thank you, Molly. Hi, everybody. I'm Urs. I'm a partner with IT Agile in Germany, Hamburg, and I work as a management consultant with leadership and teams around Germany, Europe, and internationally. And today I'd like to talk about alternatives to estimates. In other words, lean forecasting. But before we go into the topic at hand, let's first have a look at estimations. So why do we estimate? Usually it's one of three things. We either want to say when something will be done, so we want to give a date, or we want to know if we can afford something, so we want to calculate a budget for it, or we want to set priorities to have a good efficiency of cost and the use we get out of it. And when we now take these estimations into account, we look at mostly one thing, and that is the amount of work. So Some teams look at the number of features that are included in their backlogs, or we look at the number of widgets that's to be built, or we take some more ephemeral measure like complexity and take all of these into account to predict the duration, to answer the age-old question of when will it be done. However, when we ask ourselves whether estimates influence the duration in any form or shape, of course, the first thing that springs to mind is Betteridge's law of headlines, which says if the headline poses a question, the answer is no. And this is exactly what we're looking at here. So, of course, if you have the lead time, so the duration on the horizontal and our estimation and story points on the vertical, there are some dots which are just where we expect them to be. So the bottom left hand with a strong trend line to be seen there. However, some are further out on the top, so they were done very quickly in just maybe 10 days or so. That's a red circle on the top, whereas we had estimated them at 21 or 22 points even. So that's not quite what we would have expected them, how fast they would be done. And then we have some in the circle on the center, bottom center, where the lead time was quite long, with 20 or 30 or even 40 days maybe, but we had estimated just 1 or 2 or 3 points. And then of course there's this outlier to the bottom right, 76 or 78 days taken, just 2 points estimated. So how can that be? If estimations were such a great tool for predicting the duration and the lead time, this shouldn't be happening. So let's have another look. What's in an estimation? Or rather, what's in a duration? So in a duration, we have not only the amount of work, but we also should take into account the tools available. So do we have the right tools, coarse or fine-grained tools for the job? We should take into account the assignment. Who does the actual work? Is it the boss lady in front who knows all the tools, knows all the work, and has it drilled down to perfection? Or is it her uncle who just tends the workshop from time to time? What about additional tasks? Who else wants our attention? Who else distracts us from work at hand, be it at home or be it in the business? Utilization. At a certain point of time, if we're overutilized, we just get bogged down and other things have to wait. Sometimes we have to wait for people to give us additional info that we need to continue working, or maybe we need clearance to get some tools working, to get a new piece of hardware online, to get a new server running, whatever it is. And of course, there's the good old blocker, like we witnessed last year in the channel. That's a picture, an aerial picture taken from the Suez Channel in Egypt, where things just get stuck and it takes a while to get them unstuck. So in other words, there are dozens of variables influencing our work duration, but our estimates typically cover only a single one. How much work is it? And of course, if we base our planning on that, we're off. We're way off. And then if we take into account that ours is not the only work, but there might be other departments downstream or upstream, and the estimate that the customer gets on a delivery date is based on all of these somewhat skewed estimations, well, might be pretty far off. So let's sum things up about estimations. Why are estimations lacking? We have only one out of many variables. Also, estimations usually have a fixed value and don't include something like a probability. Oh, we don't say people, oh, this is a 21 with 80% probability, or this is a 5 with 100% probability. There's no room for error, but it's just a value, and such they are usually taken as commitment. This will be done as a 5 or as a 20 or in 13 days or whatever our estimation is. So to make things worse, we usually estimate early, quite early, when people ask us, what should I write in the contract? What's the deal we should do with our customer? However, when we estimate early, things are still quite uncertain. And even though we learn things down the line, we rarely update our estimations. So that's another point of error. And we hardly ever get feedback regarding the quality of our estimates. So we say, okay, the project was late, or the project took longer than expected, or things like that. But we don't learn from that. We have no means, or hardly any organization. There are some that are better at this. Hardly any organization has means to increase the accuracy of future estimates. And finally, estimates take up much time, and people usually say, "I'd rather be working than estimating." That's a grievance that we should take into account when we decide our methodology. So now that's why I'm not too fond of estimations. So I'd like to have a look at an alternative. So first of all, let's have a look at people who make predictions regularly, frequently, every day, with large effects on people's lives. In other words, let's have a look at whether people, they know how to do this. Because regular examples are a bit tame, I took a big one. So if you're from Florida or New York, or the entire Eastern Seaboard, please bear with me. This is about Hurricane Sandy. Some of you might have not too fond a memory. This was the largest hurricane ever to hit the Eastern Seaboard with, I think, $65 billion in damage. It was incredible, and even worse damages in Cuba and the Bahamas. So what we're looking at here is a weather picture published by the National Hurricane Center back in 2012, I think, mid to late October. What we see here is the position of the storm that had just formed in the orange point at the bottom. And then there's a series of black circles, which denote the most probable path that the storm will take. You see the coastlines of Jamaica, for example, colored in yellow, the intensity of the storm when it makes landfall. And then there's a white cone, which is a potential track area, as they call it. So the area where the meteorologists say the storm center will be, with a probability of 70%. And then we have it again, probability. So this is what their models tell them where the storm will be, but it's not a certainty. It might veer off to the left or to the right, probably not to the south. And on the very top, we have a bluish area, which is still circled, which is the 4 to 5 day prediction of where the storm will be. Now, this is what they said late October. Let's see how things developed. To the very left, 22nd of October, we had the image we just saw. And then 23rd of October, 1 day later, we see several things. First, the area influenced has increased. So it's not only the line of Jamaica, Cuba, and the Bahamas, but rather the Dominican Republic is now mentioned as being hit by the storm as well. So the area has increased. Also, the intensity has increased. No longer it's just a tropical storm, but rather it's a fully fledged hurricane, denoted by the yellow borders when it will make landfall in Cuba, for example. And then we see that the path of the storm has shifted. It's shifted off the coast, will tear over to the Atlantic, and so probably not hit the US. This is what we thought on the 23rd of October. And now, 2 days forward, 25th of October, the storm has taken this path, or is still predicted to take this path, rather. We see the entirety of the Caribbean now in red, with all the Bahamas Island, and then the prediction for 4 to 5 days to hit New York, New Orleans, New Orleans with another hurricane, New York and New Jersey on the north of the U.S. And this is what happened. The storm made landfall quite short of Atlantic City and ravaged New York City. So predictions, and this is what I'd like to learn from this, can change. And it's important that when the data we have available changes, we update our predictions, because That is the only way that people can be prepared for an event like this. Back then, the meteorologists didn't make the predictions as dire as they should have been, because this was an outlier. There was a weird weather phenomenon over Iceland, which pushed the storm back to the US. And so there was a 2% chance or something like that to actually be as intense as it was. But they didn't take it seriously in the end, because they didn't want to be doomsayers. Anyway, back to business. So forecasting is a probabilistic approach. We have a probability of what we will see, and things change over time. New information is integrated into our forecast once we have it available, and the probability increases if we have a shorter forecast horizon. So if we look at only 1 or 2 days in front of us with a small model, we'll be more exact, more accurate than if we look at half a year. And the model, our forecast, is usually built from observation, so the data that we have, and a model for future behavior, and always under the assumption that future behavior is similar to past behavior with a somewhat stable context. So we have roughly the same people, we have roughly stable priorities, and we have a rather similar process. And with that, let's have a look how to transfer this idea of a forecast into a world of business. And there are 2 kinds of forecasts that I'd like to discuss today. One is a single item forecast, which we'll do next. So the question is how long to complete a single task. When a client comes to me and says, hey, Urs, here's a piece of work, can you do it? And most importantly, not only can you do it, but by when will I have the answer? This is what I'll be looking at. If a client comes and says, here's an entire product for you to build, with, let's say, 35 features to include, and I have limited information on the content of those features, how long till I get the finished product? This will be a multi-item forecast, which we'll do second. So let's start with the basics. Single item forecast, how long to complete a single task. For that, I have another example, which is travel time. So my daily commute, back when we were still commuting into the office, here are some travel times. See my departure from home, arrival at the office, travel time in minutes, of 100 minutes, 101 minutes, 96 minutes, and then, wow, 153. What happened there? And then there's another rather expected time of 103 minutes, 135. What happened there? 66, 81. So it goes lower, huh? So there's something like a regular range of maybe 96 to 110, and there's a lower range of 66 to 96 or so, and then there's 2 outliers of 135, 153. So what happens is, most of the days I take the train, and it takes quite a while, but it's predictable in this 100-minute range. Some days the train is delayed, or there's work on the track or something. This is when it takes longer. And some days I take the car. The car is faster. So if somebody needed to see me and asked me how long I would take to the office, I would probably say something about 100 minutes, maybe 110. So plan my day accordingly. If I knew this was the date to be 9 o'clock sharp, $2 million deal, I would probably plan for 153 minutes time. So to not be late by a single minute. So depending on the context, we need to take more or less of the data into account and want to have a higher or lower probability to actually keep our promise or keep the forecast that we made. Looking at lead times from actual project data, we see dates of completion here on the horizontal and lead times in days, so how long it took on the vertical. So in each of the dots is a single item in a backlog that was completed. in the very beginning, we have something that took a single day, something that took 2 days, and then a few days there's nothing. Then next week there's something that took a single day, 6 days, but also something that took 91 days, and so on and so forth. Every single dot is one item that was completed on the given date and spent that much time in our backlog. And now, if somebody asks me, how long will your work take? And I have no idea what it is. I can give an easy answer based on this data alone. 85% of our work is done in 80 days or less. So I don't need to know anything about the work. I just need to know that this is something roughly similar to the work that we did in the past. Now, if my client answers, okay, 85%, that's a rather rough estimate, and that's only 6 out of 7. I'd rather have a higher certainty here. Okay, sure. 90% of our work will be done in 23 days. Okay, the client says 90%, that's better, but still 9 out of 10. How about you give me 95%? That's a critical miss only, so natural 20 for those of you. Anyway, 95%, that's fine, I say. 68 days. How about that? So that's 3 times as long, but you have a highly increased certainty that we'll actually get it done. And probably my client will say, oh, all right, I'll take 23. That's fine. And probably he or she will still take 23 as a commitment rather than a probability. But still, we have this idea of a probability in here. And maybe if these are different kinds of work, on the lower range and the higher range, we can even take a different approach here and say, okay, let me have a look at the item first. If I know it's something that I usually heuristically would put in the smaller range, then I take 90% or 85% of all the dots just below 30 days maybe. And if it's something that's usually very large, so heuristically speaking, in the upper range, I only look at the 5 dots above 60 days and up to 100 or so. So this is what we do here, and this is how I do a single item forecast. Now, some thoughts to make this more accurate. First of all, this control chart style with all the dots is not the easiest way to handle it, because it's quite hard to see when we get to 85 or 90%. So instead, I'd like to use another visualization for this, and this is a histogram for frequency analysis. So for every item that I complete, I put I increase one of these bars by 1. So if it took 5 or less days, it's the first, 5 to 10 days, it's the first bar. 10 to 15 days, it's 1 point on the second bar. If it took over 100 days, it's a point on the last bar. So the highest bar tells me what the median lead time is. For example, we had something between 20 and 25 days 6 times in the data we just seen. And then I can have a look at where 85 or 90% of my things actually are. This is what we see here. Okay, so going from there, we have various modes of these histograms can take. For example, on the left hand, we have a very well-formed histogram, which we call thin-tailed. So there's one clear mode, single peak in here, and then there's this long tail up to 100 or 105 days or so. This is usually an indicator that we have a limited amount of work in progress. We focus on getting things done instead of shifting priorities around. And maybe it's also an indicator that we have similar types of work. On the other hand, on the right-hand side, we have 2 peaks. You see one peak very early in the histogram and one peak in the very end. And this is what we call a fat-tailed histogram, multiple modes, so it's multimodal. This is an indicator that we have uncoordinated work where we have frequent shifts in priorities. So every day or two, our boss comes in and says, well, I have a great idea. Couldn't we just do this instead of whatever you're doing right now. Now, please drop everything and shift your attention over here. And every time this happens, we reprioritize, we change our queue, and the thing we just worked on gets pushed back to the end of the queue. And so it takes ages to be complete. I think most of you know this scenario. But even if we have a well-behaved boss or well-behaved stakeholder that doesn't come in every other day, I see from your reactions you don't know this kind of guy. This might be an indication of another issue, and this is that we have very different types of work. So maybe we have very quick work, some kind of work that usually gets done very quickly, some kind of work that usually takes ages to complete, but we all aggregated them in this single histogram here, which is all right. Just to get an idea of our lead times, but to actually make a forecast based on this, we need to differentiate between these types of work. So rather than push it all into a single histogram, have one for the first kind of work, one for the second kind of work, one for the third or fourth kind of work. And kinds of work, types of work, maybe anything here. Like, is it database work or front-end work? Or is it this client or that client? Or is it national or international? Or whatever kind of classification you can think of may be relevant here to find out in what bucket of work the request your customer just handed you falls, and thereby get a better prediction for these 85 or 90%. So let's sum things up here. Single item forecasting. We need to know the lead time so that it's a time elapsed between committing to a task and actually completing it. What counts as commitment in your environment may be different. So committing could either be the team starts working on it. Committing could also be, I say, yes, dear stakeholder, I'll put this in my backlog, which gives us totally different ranges of dates, but both are possible to take into account here. Just needs to be clear what it is. We need to keep track of start and end times, and this is all we need. Yeah, for all the things we've seen so far, I've only taken track of start and end times and based my prediction on that. I didn't ask a single person from my team. I didn't ask for gut feelings. I didn't ask for estimates. I didn't ask for story points. It's all rational and empirical data. We need to understand the distribution of our lead times, what we've seen on the slide before, whether we have this clear-cut, thin-tailed distribution or rather mushy, fat-tailed distribution, and then need to work with the distribution a bit and have this classification in if it's fat-tailed. So strive for thin-tailed distribution. And usually I suggest to my clients that they go for 85% as a prediction value. So 6 out of 7 as a probability, that's quite good. But you also, of course, could go for 90%, that's 9 out of 10. And very importantly, do not take into account unfinished work. This is only about completed work. Work that's not yet finished. You never know, even if it's 95% done, I'll just put the last bells and whistles on it tomorrow. Tomorrow the guy gets sick, and then the project gets pushed back, and suddenly 100 days have passed and you never knew why. So only consider finished working. All right, so that's single item forecasting for one item that our stakeholder wants to know the completion date of. And now we move on to multiple item forecasting, how long to build a product. And that is where things get interesting, because the very simple idea here might be, okay, I have one item done and I know how to predict this. So when I do 35 items, why not just sum it up? 1 item, 2 item, 3 item, 4 item, and 35 times my 85% value, I'll have an answer for you, dear client. So it's 35 times 18 days and we're done. And the answer why we don't do that is because we don't build 35 features in a series, but rather build some of them at the same time, intermixed with each other. We have not a single person working on it, but a whole team, and so on and so forth. So we need to take some things into account here. And this breaks down into 2 questions. Question 1 is, how much work are we actually facing? And question 2, how quickly can we as a team or as an organization complete it? So again, we need to know what is the process we take into account here, what's the point of commitment, what's the end point, and then have a look here. So let's assume we have these 35 epic level features to complete, which is the big new thing that we want to build. The first question we need to look at is how many backlog items are these in total? So of course, 35 epics, some may break down to just 1 or 2 things, some may break down to 20 or more things. We don't know. So what do? We could break down some of these features, or we look at similar work we've done in the past, and thereby say, okay, back then, adding a credit card access to our product was 6 items that we had to deal with. So probably it's in a similar range now. So to rule out bias, I would suggest to not take the first 6 or last 6 or the 6 that we are most familiar with, or rather the some features, but rather randomly select them. So generate a number of random numbers between 1 and 35 and take these epics. No matter if you're very familiar with them or if you're completely unfamiliar, just take them and break them down or compare them with past work to get an idea of how much work it will be. So in this case, I've taken 8 samples. I've broken down 8 of my features into work items. So feature 4 is 12 work items, feature 7 is 6 work items, and there's 9, 8, 9 again, 8 again, 6 again, and 25. So what now? What about the remaining 27? We don't want to break down everything. Would be a forecast then. So we could just say, the rest will be easy. Just let's assume they all lost 6. Best case scenario. So, is this a probable outcome? And all of you who are shaking their head right now, that's right. That's absolutely improbable. So, while 245 backlog items would be very nice to see, we probably won't see that. Okay, so now it's the pessimist's turn. What about we assign 25 to all of them? So the worst case scenario, maximum sum, 758 backlog items in all. Is that a likely outcome? And all of you shaking your heads now. No, it's not a likely outcome. That's right. So it's as unlikely. It's just a more safe bet to say we will have 758 because nobody complains if we are faster, but many will complain if we're late. So let's take another guess. We could just roll the die. So take an 8-sided die and write the numbers of 6 and 6 and 8 and 8 and 9 and 9 and 12 and 25 down on this die and then roll it. And for every of the gray fields, assign the number we rolled. This might look like this, random samples. So we have a 9, a 25, an 8, a 9, a 6, an 8, a 25, and so on and so forth. And it's quite a number of 25s that we rolled, given that the 25 only occurred once in our original sample, but still. So we have some values here. Once again, this a likely outcome? No. It's a bit more likely than what we've seen so far, best case and worst case, because it takes the distribution of the values we know into account. But still, it is just one random sample that we took. So this is not perfect still. What do? We stick with this idea of random assignment, but we don't do it once. We do it lots of times, 1,000 times. So we roll these 27 dice not once, but we roll them 1,000 times for 27,000 dice rolls and note down the totals of numbers rolled. This is what in the field they call Monte Carlo simulation. So, and if people ever ask you, what does Oppenheimer have to do with agility? This is the answer. Because back then in the Manhattan Project, they used this idea of a Monte Carlo simulation. Actually, Fermi, the physicist, developed this idea to track particle movements and how the bomb or the elements would actually behave. And we take this idea right out of Oppenheimer and put it to use here for our work. And because rolling 27,000 dice, I'm a role player by heart, so I know a thing about dice. Rolling 27,000 dice is not fun. This is why we have computers. So we ask our computer to do it for us and note down the totals. Once the system is done, we get something like this. And you know now, this is a histogram. And we see on the horizontal the total story count that the system has forecasted. So how much work is it? And we see on the vertical again the frequency of items. And then we can just see our estimates here. With 85% probability, we are facing 400 or less backlog items in total. With 95% probability, we would be facing 423 or less backlog items in total. That's okay. That's not that big a difference. That's fine. What's important to know here is that this is not a stable outcome. So the next time you ask a computer to roll these 27,000 dice, you will get a similar form in the histogram, but it won't be the exact same answer. So maybe the next time it will tell you it's 390 with 85% probability, or 440 with 95% probability. That's very much possible because the die falls a different way every time it's rolled. So this is how we get to the answer of how much work is there. Take some samples, break them down or compare them to past work, then assign these numbers to our die and have a Monte Carlo simulation that is 1,000 times of dice rolling to get this histogram. And there's the second part of our question, which is how quickly can we complete it? And to that end, we look at past data. What we have here is a log of our daily throughput of backlog items. Colored in red, it's bugs that we fixed, so issues in our product that no longer are. And colored in blue are stories, so anything that's actual progress toward a given goal. So we consider this throughput in stories. And what we see here is on the horizontal, we have calendar dates. And on the vertical, we have the throughput in items. So on the 1st of November, 2023, we completed a single story. On the 3rd of November, 2023, we completed 2 stories. And then there were 2 days of no stories completed. Then there's 2 stories again on the 6th, 1 on the 7th, and so on and so forth. Then there are some days with more stories completed. For example, 27th of November, there's 5 stories. In early January, we have 2 days in sequence with 5 stories completed, and so on. So we take data from the past 3 months or so, and now we can, this roughly 100 days covered, and now all these numbers of stories completed, 1, 0, 2, 0, 0, 2, 1, 0, 0, 0, and so on, we assign to a big pool of random numbers, and we draw samples from this and sum them up, and take this as our predicted throughput for the future, under the assumptions that we mentioned earlier, that we have a rather stable team, a rather stable process, and no huge shifts in priorities. Take these randomly drawn throughput values as our predictions for the futures and sum them up until we reach the 85% mark of 400 or less items. And because doing this once is no fun, we once again do this 1,000 times. So we have 2 chained Monte Carlo simulations, first to see how much work it actually is, then to see how quickly we'll get it done. And you know what's coming. There's another histogram. So here's a histogram of completion dates. On the horizontal, dates. On the vertical, frequency, how often this date was the result of our second simulation. So, and now we can give a very clear answer to the question of when will it be done. Given a start on February 1st, so you need to have a start date, we will be done by week 35, which is end of August, with 85% probability. Or maybe with 95% probability, we will be done early September. And this may be that we're far quicker that we're done someone in July, or maybe even, no, it's 1st of July is the first occurrence, first date that it's given here. Could be that we're that fast, but there's a very little chance. And could be that we are slower. In 1 out of 7 times, we won't make it. So if push comes to shove, that might happen. But 85% or maybe 90% usually is a good number for forecasts such as this, because most of the times, so for most projects you start, you will keep the promise. And this is what your stakeholders will look back at in the end. Do you usually keep your promises? If you give me a number, can I rely on this number? And if one number out of 7 or one number out of 10 is off, that's fine for most people. But if you're like at a 50% hit rate, so if you would always give the line in the middle, it's coin toss odds. So you might hit or you might miss, and nobody knows in advance. And that's what I call bad stakeholder management. So let's sum things up and get over to the Q&A. For multiple item forecasts, we take the random samples from past or upcoming features and then simulate the features not sampled via the Monte Carlo method, and so forecast the amount of work. Then we have to look at our throughput and the items that were actually done over the past 3 months, 100 days. You have it. And simulate our future throughput until we reach the forecasted item count. And finally, we forecast the completion date using the 85th percentile. And whenever new data becomes available, so when we now actually get to breaking down one of the things we just simulated, or actually do some work and have an actual throughput, we update our forecast. So this is something you can do again at the push of a button, and that is the magic of it. You don't need to summon all your team members and say, guys, we need to re-estimate all the work now given the things we just learned last week. You just push a button, the model works. A minute later, you have a new forecast. That's pretty well invested time, I guess. So if you don't trust some random guy that Molly dragged up from the internet to influence your product forecasts, here's some work on this. Troy McGannis from Seattle, Washington has beautiful work done on his website, focusedobjective.com, or in his GitHub repository. Links here, and I guess Molly had pulled up the link somewhere for you to see. There are Excel sheets where you can do just the things I've just shown you by inputting your product data into Excel and then get these prediction out of there, especially the story forecaster Excel and throughput forecaster Excel are great work, and it's all available for free for you to use. And thanks to Troy, he's a great guy. If you're using Jira, there's a tool called Nave, which is an add-on which uses Jira's API to do just these simulations and forecasts based on the data in your Jira. Of course, it's a paid tool, but still it might be worth a look. Business Map is another tool like that, but it's an independent tool. It's also worth a look. And finally, there's a great work from Dan Vacanti from, I guess, Philadelphia. It's called When Will It Be Done? It's a book he wrote, available, I think it's self-published. And Dan goes through all these things step by step and adds much more than I could do in this limited time here. Much of what I've just shown you is owed to Troy and to what I learned from Troy and from Dan. So both of their works are worth looking at. And finally, if you still don't trust us, all of us, just do it. It's not much work, and you don't have to throw out your estimates. You can just have it run in parallel and then look at the results. See what your estimations told you, see what the forecast told you, and if you thereby get to trust the forecast, maybe you've learned something and can use it in future. All right, thank you. I'm Urs from IT Agile in Hamburg, Germany. Thanks for joining us tonight. Here's all the data you need to get in touch. I'll be available for questions and answers. And of course, if you want to get in touch afterwards, be it to chat, be it to understand these concepts, be it to gasp, hire us or hire me for a talk or a workshop or whatever. CSPO training, I'll be your guy. Thank you very much.
All right. Thank you so much for that. I am not a math person or graph person, but this made it feel a lot more accessible. So thank you for that. We have a lot of questions in the Q&A, and we have about 15 minutes, so we're going to try and get through as many as possible. So let's start. So
Sure.
somebody asked, what data do they use if it's a new team with no previous data? How do we adopt this method or something similar to estimate?
Oh, that's great. So if we have a new team with no past data available, we might want to look at past data from other new teams which are in a similar scenario. So maybe we find some people who were in a different spot, or we might still want to look at similar projects. So at many companies I've worked with in the past, this idea of that a project is a one-off thing that never happens again is actually not so true, but rather there are many projects that are repeat work of things we did in the past. And so we might want to look at that. And we need to take the data we get from that with a grain of salt. So do a prediction, do a forecast, but still maybe assign it a lower probability in the beginning until you have some data gathered from what this team actually is capable of doing, and then update frequently. That's the only honest answer here, to not pose as confident as you might otherwise want to pose.
Right. Is there a way to anticipate or estimate for overlooked or emergent requirements?
Yes, actually there is. So if we think back to what we've seen here with the items that we assigned, so what we might do if we consider past work instead of broken down work, we might have an estimate of items in total from the past work. So maybe we said that connecting to a new credit card provider would be 4 items, and then we did it, and there were 2 things that we overlooked. So we had this +2 factor 1.5 to multiply it by, and for another thing, connecting to a new bank or something, we have 8 items here, but actually it only were 7 in total. So we have a smaller factor, and we can multiply these expectations. Actually, if you have a look at the spreadsheets I mentioned, you will find just that question: how do we expect the predicted amount of work to break down from usual factors are 1 to 3 there of additional items discovered. We just take them into account and multiply. It's just straightforwardly done.
All right. Next question. Is there a way to account for Parkinson's law when looking at past performance to predict future timelines? Perhaps a past project could have been done quicker if there was an earlier due date. And for anybody who, like me, is not familiar with Parkinson's law, a quick definition is the Parkinson's law is the concept that work expands to fill the time given to complete it. So basically, work gets bigger if you give it a further out deadline.
It's interesting to take that into account, but given that we're working with empirical data, so we're basing our predictions on how long work has taken in the past. We won't increase the effect of Parkinson's law. We won't reduce it, but we won't increase it either way. So I don't think there's a good way to reduce this and still be true to the forecast that came out of it, because we would lie to ourselves if we said, oh, this will be done faster if I just tell people to be faster. Yeah, that's it. So it's a good question. It's an interesting concept. If you do try it, please tell me about the results. You'll find my mail address on the last slide.
All right. Can we use this forecasting technique to help with sprint planning?
Help With sprint planning. Sure. Yeah. So I need to sort my thoughts because I usually use it for a longer time frame. So it's something for whole product projects I'm looking at here, not a single sprint planning. But looking at sprint planning, I can use it to predict the standard amount of work that we get done in a single sprint. Like looking at the past 10 sprints or so, how much work items did we complete there? How many new bugs arrived here? And then have a look at these 85%, and thereby give a prediction or a forecast of the capacity of the team for the upcoming sprint, and then pull items from the backlog accordingly, or rather prepare the backlog so that the sprint goal might be reached with the number of items that we predicted, and be quite sure that the rest may be completed. So the 90th or 95th or 100th percentile, but it's rather unlikely.
For calculating lead time, what would you consider as the start time? When the item is added to the backlog, when it's been refined, start at the first sprint that it's allocated to, or when they first start working on it?
Excellent question. Thank you very much. That totally depends on why we do this. If we're dealing with customers here, people don't care about when we start working on it and when we hand it over to the next department. The customer cares about when does he order the product and when is it delivered. So I would take commitment to the customer's order and then delivery of final product as my start and end date, which might amount to adding it to the backlog and then putting it in the done column or whatever it is. If it's more about optimizing our internal workflow, it's your best guess. So probably I would take something like post refinement. Whenever we say it's ready to be worked on, and then until we hand it down to the downstream department.
All right. If the stories are not of the same size, doesn't Monte Carlo get confused when calculating prediction?
The stories are not of the same size. No, actually it doesn't. Because just on the slide I'm showing right now, we only take into account the amount of items. And with that many items, some will be large, some will be small. And also, this is why I said 2 slides earlier, please randomly select these things to rule out bias like this. This was too small, this was too large. It will not get confused. The results may be off if these 12, 6, 8, 8, 6, 9, 9, 25 are very small results by an odd chance. But once we start working and update our forecast, we will see what the actuals are and can update our forecast accordingly. So no, it won't get confused, but you might see shifts in your forecast if you hit a very low range, or if you hit a very high range, as we've seen with a hurricane in the beginning.
If the constraints change for the new project, can you still use the past predictions?
Constraints change. Depends on the size of change. I would at least try to do it because it's hard to predict, no pun intended, when a change will be too big for it to be still valid. But I would take it with a grain of salt. So maybe make a note in my calendar here constraints changed, and whatever comes after may deem closer inspection.
All right. Why is this method better than story points and velocity?
Sorry, I didn't catch that. Why is it better?
Mm-hmm. The question is, so why is this method better than story points?
Okay, that's a master level question. Why is it better? because first of all, we don't rely on gut feeling, but on past data. We don't take up very valuable time from our coworkers, but instead can do it on our own. And because it's much quicker and repeatable than anything we might do with story points. However, this doesn't take this doesn't give you one of the key advantages of estimation on the other side, and that is an exchange of minds about what is actually to be done and what is to be built here, because this is just the raw number game. People need to understand what the end goal is, what effect you want to have on the market, on the product, on the customer, and what to actually build. And this is something that only dialogue can give you. I mean, everybody remembers these 3 C's that Ron Jeffries came up with back in 2000 or so. That it's about the card that we write, the communication that we have amongst ourselves and with the client, and the confirmation, so acceptance criteria or whatever, and that the conversation that we have is 80% of the value of every single item. So, and this conversation is not yet taken part when we do a forecast.
All right, I think we have time for a few more questions.
Sure.
What, where was I had the question I was going to ask you, and then I scrolled away from it to read others. What tool are you using to extract the statistics?
To extract the statistics. So the base data of commitment, point of commitment, and finalization point or completion date, I can either note them just down an Excel spreadsheet or pull them from Jira. Jira just has them, or if I say Jira, I mean any Jira analog as well. So Microsoft, Azure DevOps, or JetBrains, TeamCity, or anything you have. All of these have the essential data that you need. And I really like to use Nave that I mentioned, because it just connects to these things, and gives us a very easy way to do this, and also to rebuild the forecast in any way. And apart from that, Excel and spreadsheets usually do fine. So no need for further tooling. Now it seems like my video is broken off.
Yes, the video has broken, but we still have you for audio. And since we're at the very end, I think we're okay.
Okay, that's okay.
Yes. So one final question before we close out. So would you recommend presenting both the thin and fat-tailed histograms?
Oh, I strive to go for the thin-tailed histogram, but if I have a fat-tailed histogram, I need to work with that and find out why I have it, and whether I need to change the way of working with my stakeholders to have more fixed priorities, or whether I need to find out what different kinds of work I have, and to classify the work that's incoming, to get a series of thin-tailed histograms. These are not so much for presentation, but rather for making sense of things, and then being able to judge the incoming work in the single item forecast scenario properly.
Great. And second, I am answering a quick question.
Okay.
All right, so I think that will wrap us up for today. Thank you so much for this wonderful presentation on lean forecasting and creating better estimates. To everybody who joined us, thank you for coming. We love sharing this sort of content with you, and we encourage you to keep coming back. At the end of this, you will get a quick pop-up asking you to take a survey. We would really appreciate it if you do take it. As for this presentation, the slides, and the on-demand recording, you will get an email sometime tomorrow letting you know that the on-demand recording is available for viewing. So you'll be able to watch the recording, access all the related content. Anything that's on the screen you're seeing now, you'll be able to continue accessing after today. And I will also be sending out a link to any Scrum Alliance members to auto-claim your SEU for attending this session with us today. Again, thank you all so much for coming, and we hope to see you at our next webinar.
Excellent. Thank you.